Atomic or fission weapons. The first generation of nuclear arms relies on nuclear fission, the splitting of heavy atomic nuclei, such as uranium-135 or plutonium-139. A neutron collides with such a nucleus, causing it to split and release a large amount of energy and additional neutrons, which in turn trigger further splits in a rapid chain reaction. There are two main mechanisms used. Gun-type design. One mass of fissile material is fired into another to reach critical mass, used in Little Boy, Hiroshima. Implosion design. Conventional explosives compress a fissile core into a supercritical state, used in Fat Man, Nagasaki. Fission bombs are measured in kilotons, thousands of tons of TNT equivalent, thermonuclear or hydrogen weapons. The second generation, fusion weapons, generate vastly greater energy by fusing light nuclei, typically isotopes of hydrogen like deuterium and tritium. These weapons use a fission bomb as a trigger to compress and heat fusion fuel to temperatures comparable to the sun's core, initiating fusion. The most common architecture is the Teller-Ulam two-stage design, where X-rays from the primary fission explosion compress and ignite the secondary fusion stage. Yields are measured in megatons, millions of tons of TNT, often making them hundreds to thousands of times more powerful than pure fission bombs. Strategic versus tactical weapons. These terms categorize a weapon by intended use rather than physics. Strategic nuclear weapons are high-yield thermonuclear warheads meant for long-distance delivery, targeting cities, military hubs, or hardened facilities. They form the backbone of national deterrence and are deployed via the nuclear triad: intercontinental ballistic missiles, ICBMs, submarine-launched ballistic missiles, SLBMs, and strategic bombers. Tactical or non-strategic nuclear weapons are lower yield and designed for battlefield use, striking military concentrations, airfields, or ships. These weapons risk escalation because employing any nuclear device, even a small one, may be viewed by adversaries as crossing a threshold toward full nuclear conflict. Neutron bombs. Enhanced radiation weapons. A specialized class of low-yield thermonuclear arms, neutron bombs aim to maximize lethal neutron radiation while minimizing blast and heat effects. Their cruel purpose is to kill enemy personnel, especially those in armored vehicles, while leaving structures relatively intact. These were developed and tested during the Cold War, but few, if any, remain deployed in modern arsenals, bunker busters, or earth penetrators. These are nuclear warheads built to destroy underground or hardened targets. They use a rugged, pointed casing and specialized design to survive impact and penetrate the Earth before detonation. The B-61 Mod 11 is an example, configured to burrow into soil or rock and generate powerful ground shock, making it more effective than a normal air burst against buried bunkers. However, it cannot penetrate all types of terrain, such as deep granite. Salted or radiological doomsday bombs. These theoretical weapons are intended not just to destroy, but to contaminate. A salted bomb is a nuclear device laced with a material like cobalt-59. Upon detonation, the intense neutron flux transmutes it into radioactive cobalt-60, spreading deadly fallout over a wide area. Their purpose is area denial, not immediate kinetic destruction. No known salted bombs have ever been built. The intent behind such a device would not be battlefield victory, but long-term contamination, to make entire regions uninhabitable for decades or even centuries, a weapon of area denial rather than conquest. If you found this explainer useful, please like the video, subscribe for more clear, concise breakdowns, and hit the notification bell so you don't miss the next one.